All right, let's go back to the Haber-Bocsh process in ammonia synthesis so that they are successfully make this reaction happen. Okay, so mentioned at the beginning that this equilibrium is look easy, but really difficult to very difficult to make ammonia because it's an exothermic process, so energy as a product. If you increase the temperature, the reaction go quick. But if you increase the temperature, like you add heat to this reaction, the equilibrium go backward, right? At low temperature, of course, this equilibrium really favor the formation of the product. But at low temperature, the reaction go way too slow. It takes millions of years to reach equilibrium. You're not gonna get any ammonia, right? So Haber and Bocsh did this. Number one, increase pressure, right? How does this help to making ammonia? Increase the pressure. Well, high pressure. Take a look at the gas. So there are 2 moles of gas on the left side and 1 mole of gas on the right side. If you increase the pressure, the equilibrium will realize that, oh my God, too much pressure here. So we have to move to the side that produce less gas, shift to the right. So making more ammonia. Okay, and as ammonia is making, they make like a machine, the reactor, whatever they call it, the whole industrial process to remove ammonia as it's being produced. Remove the ammonia. What happened to the equilibrium? Well, go forward as well to make more product, right? Now, adding a catalyst to lower the activation energy to make this equilibrium reach the equilibrium more quickly, right? The only problem is, so they do this reaction at high heat. Of course, high heat will favor the formation of the reactant, but we compensate that with adding more pressure. Okay, so it looks something like this. So these are their process, right? So they're adding nitrogen gas and ammonia at very high pressure, so 300 atm, really high. So ammonia and nitrogen come down here. Heat exchange, so really hot in here. The heater is really hot in the reactor, right? There's a catalyst chamber, so the catalyst in it. The hot catalyst, the hot chamber make this equilibrium produce more reactant, so favors the reactant, but adding the high ATM, high pressure, compensate that to make more product, right? Catalyst makes the equilibrium reach equilibrium faster, right? So nitrogen gas and hydrogen gas gonna react in here, making ammonia. So ammonia come down here. And at this portion of this scheme, this portion is a condenser. The hot ammonia is coming out, so the heat exchange really hot in here, right? Ammonia is coming out, so it's a gas. Right here is really cold. Ammonia condense back down. So basically, we're removing ammonia as it's being produced. So ammonia come down here, and that makes this equilibrium going forward even more. Okay, so cool it down, ammonia come down here, right? And nitrogen and hydrogen go back down, whoop, go over to react more, so the left over. Okay, and that make Fritz Haber got the Nobel Prize because of this process. Okay, all right, so we got one more video. It's just all practice. It's just for you, so I make this one for you. All right, let's take a look at